Okay, hello, welcome to the sixth stream of my design work on the Raspberry Pi Compute Module 4S. Since the last time I worked on the design offline, let's say, so, but not a big deal. I will show you everything what I did. Basically, I fan out this IC. This is the USB to Ethernet controller. So yeah, basically this part plus the eFuse for the IC. The IC is enabled from the Raspberry Pi by one GPIO signal, GPIO out from the RPI. So the IC is enabled then I slightly modified this part with the voltage translators. I rotated them by 90 degrees clockwise. So the ports facing the header is on the left edge of the IC, and the inputs from the Raspberry Pi, or not inputs, yeah, the interface with Raspberry Pi is on the right side of each IC. Basically, all ICs copy the same layout. You can see that the last one, the fourth IC, uses only two ports, two signals, and that the signals coming from the third one going like a quite long path from the IC to the header, and that I could share, let's say, to split the signals. Here are two, here are 8 of them, so I can split them to 5 and 5, but I didn't bother to do it because yeah, the PCB layout is not so crowded, is not so difficult, and it means that I wasn't motivated to do that. If you replicate my work, or if you would like to, because the entire design will be released after it's finished, so you can redo this part of the circuit if you want. It's up to you. Then I worked a little on the SD card interface. I realized that in the last design, in the original design, frankly, I have used this SD card with the ESD diode arrays multiple times. So I copied the entire block as was, or unblock, as we can say, and the previous design uses the traces that were coming through the ESD diode arrays to the target, or from the target, from the host. But this time it's much easier and reasonable to route the traces from the inside of the SD card footprint. So we have two options. One option is to keep these arrays as they are and continue with PCB layout on other spot of the PCB, or to replace the arrays with the discrete diodes. Yeah, it's a question. We have 3 more of these arrays here near the HDMI connector. So these 2 arrays are not the only ones on the PCB. So it means that it doesn't, let's say, complicate the BOM, because the BOM line is already there with the arrays. So I decided to keep them. There is plenty of space for removing them from the or replacing them with discrete ESD diodes. It's again up to you. I decided to keep them as they are. I kept some clearance in between the SD card traces, basically to meet the best signal integrity or the best possible signal integrity as we can do at the moment. Yeah, not a big deal, but yeah, I did it this way, and I started routing the RPI side of the voltage translators. So I used the bottom layer, and I will continue using the bottom layer because there can be some, let's say, crossings and majority of, not majority, but yeah, I think the majority of signals are going to the upper edge of the SO-DIMM connector. So anyway, I can't trace them. I can't route all of them. There are 24 plus 2, 26 signals. So you can see that there is no space to routing them in between the pads. So there must be let's say, yeah, a lot of vias, the via array from the top layer to the bottom layer for these signals. So I decided to place the vias near the IC output, or yeah, the low level edge. So yeah, you can see it. So anyway, we can continue. So last time I finished, or I stopped my work with routing these signals. So I will continue with the rest of like 18, the rest of signals. There are 18 of signals to be routed. So I will continue, and then we will see. So yeah, similar way, there is no need to change the plan. The only thing is that there is the ground via here, and I don't want to push it inside the, like, beneath the footprint, the same here. Ideally, I will place it here. Yes. Like this, exactly. There is quite space for the decoupling capacitor that can be moved closer to the footprint of the battery, but no need for it right now. And yeah, I will take a little bit shorter corner in comparison to the GPIO27 on the left side, as you can see. And my short tip for routing these long traces is that I recommend to stop slightly below where the neighboring trace ends, because when you stop here, KiCad sometimes create like this unnecessary short end of the line of the trace, and when you finished like near the end, you can it's hard to explain, but I push to the left side, but there is a trace on the left side, so the clearance is defined and the trace is simple and short as possible. So all the way I'm like pushing to the left and copying the shape of the neighboring trace on the left hand side. So this is my first take, and we will see how it how it will deal with this ground via on the right side, this one. We already know that it's impossible to route all the signals in between the ICs, but not a big deal. I will continue. Yeah, we see that was the situation. So yeah, not enough space, so I will continue here. Not a big deal. The ground copper pore will be on inner 1 layer, inner 4 layer. So the adjacent reference plane to the bottom signal traces is the inner 4 layer. And yeah, I can move the signal back, move the trace back to the neighboring one. This way. Yeah. Yeah. Maybe we can make a short measurement, simple measurement. It seems that 2 traces takes about 0.83 millimeters or 86, maybe 86. And when I route this track this way, there can be the gain of, yeah, it seems that you know what, I will try it quickly. And if it doesn't work, I can always hit the undo button multiple times. Yeah. This via is this way. Okay, I think it's better. I think it's better, less corners or fewer corners. Yeah, I like it. Okay, so now there must be done a little cosmetic work because the traces, as you can see, are not. Hi, Lionel. Hi, thank you for being here. The traces needs to be rearranged, and this is exactly what KiCad does. I don't know why. It takes the finishing element of the trace and keep it as is. The previous versions of, not previous versions, I think version 8 maybe started this with this behavior. I don't remember exactly, but it's not since ever. It started like 2 years ago. I don't know how to avoid it. It's like that. So we can inspire ourselves with the same strategy as before. So directly to the, like upwards. Then here, slightly close together, yes, exactly. And now all the traces will copy the trace of the neighboring one. Yeah, I can see an issue here. Here is the decoupling capacitor for 5 volts, and we need a ground via. Very important thing. So we have to put it here. Here. Okay. The same here. Luckily, the clearance limits for the current stick up is very friendly, but here is a disaster as well. So I have to change the layout immediately. Yeah, last time I didn't. When I worked offline on the PCB layout, I didn't notice that here is the issue. Usually I route all the ground vias as the last action, so I keep this job to the near the end of the PCB layout, and this time it makes me forget. It made me forget to the ground via. Now it's better. Okay, so the last two. And we have the bottom one, and here, okay, here is the left one, and here is the right one. So, okay, so I will go this way, because otherwise the traces would cross. Okay. Okay, so we have 4 rivers or 3 rivers and a pair of traces. So, okay, I will continue to approach the target destination. I'm not a good chess player, so I don't have prepared the following steps. So that's my first take. Maybe I will have to redone. No, I don't know. Redo. I will have to redo, maybe. Okay. Yeah. Yeah, there is plenty of ground vias, so I will start with them because there can be limiting for the entire PCB layout job. So I will start here. Yeah, I can even start here. Yes, the thickness of the trace exactly copies the thickness of the pad. That's what I want. The maximal connection. Okay, so Yeah, I used this one as the return path via for the USB connection that must be done here. But now I can see that here is not enough space in between the ground vias for the pair. So let's try. I will place them. No, I will place them to the bottom. My plan is to dedicate all the inner 2 and inner 3 layers for power. So I will use the bottom layer for routing these pairs, this pair. Yeah, you can see that this via is definitely, or this one. Maybe I will move it. Yeah, maybe that would be the best way to keep these ground vias in line, just for the sake of aesthetics. And now create a little bit of space for the better position here. Yeah, I think that's better. I will continue with the routing of this pair. Okay. Hi, Ivan. Thank you for watching. So, oh, nice. So let's continue with the ground vias. They set some constraints for the traces coming from the voltage translators, which is not the case of this spot, but when I do something, I like to do the entire way, not just part of it. So now, as well, for the sake of the manufacturing smoothness, to avoid some manufacturing issues, I'm placing all the ground vias using the same trace width, using the same via size and distance from the pad, so to avoid any unwanted behavior during the soldering. This is a fine pitch connector, which is like kept on spot using these mounting holes, but yeah, there is some tolerance. So we have this section done and the second one. It's a monotonous job, but it's a part of the PCB layout. Okay, and what about the bottom line? Hi, 𝗶𝗶𝗀𝗻. Hi, how are you? Thank you for watching. So about the same distance. Yeah, I don't want to measure it and won't, but a similar position as above. I always try to place the vias like outside of the connector, not on the bottom, because if something happens, yeah, there can be like incorrectly connected pad, like I mean the schematic mistake or pinout mistake for the connector, and whenever the short trace with via is beneath the connector, it's disastrous. So I always try to fan out at least the ground connections, not below the connector, but outside of it. Yeah. So I can already see that first collisions are on the table. Not a big deal. This is why we are doing it. So I will continue with the ground vias, and then I will split the route layers in the spaces in between the ground via connections. It looks like 2 traces will fit in between the vias, maybe 3, but I think 2. Good morning, Mark. Thank you for watching. Yeah, that's nice of you. Thank you. The position of these test points is like working or draft version. From the sake of usability, it's one of the worst positions I could choose, because it's basically beneath the plugged in RPI compute module. Yeah. But I don't count with them as like, I think we won't need them, so I place them beneath. The other possibility can be to move them to the bottom layer, but I decided if there are some issues, there is always possibility to solder the thin wire on them and like route the connection outside of the Raspberry Pi. So yeah, I'm well aware of this, but I don't know. Maybe let me think about it. Maybe there is a spot for them. Maybe then can be distributed along this area. That could be practical, I think. So yeah, Yeah, I think I changed my mind. Maybe I will place them here. How many of them is there? Like 14, 16. Okay, that can work. 16 next to each other. Yeah, okay. So more to do, but it will improve the design. Yeah, definitely. So, okay. So I will start with them. Right now. And I will use the trick I will show you. Hello, 𝗶𝗲𝗀. I am not sure if I pronounce your name correctly, but thank you for being here. So as I said, there is 16 of test points, and we can simulate the situation after. We will need a description, which is at least 𝗏𝗏𝗺𝗏. I would say that 𝗏𝗏𝗺𝗏 is the best description. Maybe we can use this. Yeah. So it means that one spot takes 4.44 millimeters. You can see it here. Here is a working scale, not working, like auxiliary scale. So it means 4.44 is the space needed for one test point and the label. So we have 18 of them. 18 or 16? 16. 16. I'm sorry, 𝗏𝗏𝗺𝗏. Yeah, thank you for explaining. So 16 times 4.44 is 16 times 4.44, 71. So let me measure if we have enough space. So here is 0, and the last is here, 42. Okay, it's not enough space. So we have to make the label shorten or move the entire thing further to the left, like here, and use a smaller label. Like this one, or we can even use this strategy. How it looks. Not good. But only 45. I would like to like use something that tells that it's I/O port. I don't know what. Maybe this way. Yeah, that can work. Let's make some measurements. So the space needed for one label plus test point is now 287 times 16, 46. What's our budget here? 45. Okay, it can work because I can move this via to the bottom or to the top of the footprint, and yet I can move this further from it. Yeah, it means there is enough space for them. Okay, so again, there is we have a budget for them, the space budget, and there can be placed like this. So the X position is now, and we have this 2.74, let's say. This is, I think, even number I used before. No, I said 287. Okay, 287. So position relative to from this is our reference. Item is this. I, by intention, used ×1 in convention because it stays there and I can only change it to 2. It's a little of manual work because I have to change the index, but it's much faster than anything else. Yeah, I can use the create array from selection, but it means that I would need to probably change the reference designators of each test point, which is much more difficult than this because now I only increment the index, which is piece of cake. Okay, so we have an array of test points with the future labels. Now I can use the create from selection grid array. We have 16 on one layer, one row, 287, and source items remain in place. Yeah, all the labels will be copied, so all of them will look like 𝗏𝗏𝗺, but I will edit them later. So this is what our array of test point looks like. I think it's good. What we need to do is to move this one a little bit upwards to be in line with these, because I would hate that there would be an offset. This way, much better. Yes. And this way, this one must be vertically aligned or horizontally aligned with this one. Yeah, that's nice. That's exactly what I wanted. Yeah, I did a good job that I decided to remove them from beneath of the SOD module, because yeah, I realized when I explained it to you, my motivation, that it was a bad move. So let's get back to work. So we finished the ground connection job here. We have some constraints where to route the, what's this resistor? Yeah, that's the permanent. Okay, that's the preset for USB OTG that will stay beneath the SODIMM because it won't be touched, I think, never. So we can I'm trying if three of them fits. Yeah, 3 of them. Okay, so I can place 3, 3, and 2. That's probably optimal. Yeah, it even looks quite good. We have plenty of space, so I could split them into pairs, not triples and pair and a pair, but yeah, I think it's good. So I will continue with this stream. So now we will see if there is enough space. No, it isn't. Okay, so I will continue. This connection must be solid. Okay, there can be a conflict with GPIO26. We will see. We will see. It won't be the only one. Yeah, I was facing the decision whether to rearrange the signals coming from the RPI header and yeah, like to meet the requirements of the SODIMM header and SODIMM connector and RPI header, or the voltage translators, or to make it more friendly with the RPI header and the voltage translators. So I decided this way. And as you can see, there are some crossings, but it's a PCB layout job. It's not a big deal, but yeah, there are more issues than I expected. Maybe I will break some rules, because I think sometime I will route the connections beneath the connector. We will see. We will see. What's this signal? Oh. I think it's not reasonable to route them upward, because it would make more issues than needed. So I think I will use the strategy like older or old PCB layout engineers followed, like one layer with horizontal lines and the second layer with vertical lines, because it's exactly what we are facing now. We will see. There are some small corners, but I will correct them later. My first take is here. Hi, Hammer. Thank you for watching. Okay, so let's continue and we will see how it goes. Maybe this can help. I'm doing it for making a space for the via connection here. So we set 3, triple, triple, and double. Okay, and the pair. But just in the center, in between the vias, like evenly distributed. Yeah, thank you for confirmation. Yeah, that's exactly what I meant. Yeah. Yeah. Thank you. I will correct these corners because I don't like them at all. Oh. Here is only 7. I forget to route one signal. Oh. I can see already issues with the layout, but we will see. I think there will be a lot of rearrangements due to the, yeah, maybe this will be like here, or yeah, major. I don't know. Maybe I will move these signals to another layer because there is not enough space for them. Now I can see that I should have changed the pinout of the voltage translators to meeting the optimal routing for the SODIMM connector. Now I'm pretty sure about that. Yeah. I didn't expect issues with this, but we will. We have plenty of time. No, plenty of time. No, we don't have. I'm planning to work for an hour and a half, that's about. Well, we will see. So basically now I'm changing my decision to use only horizontal routing for one layer and vertical in another one because of the time constraints. There is not enough space for all the tracks in between the vias. So there is not enough space for the, okay, so slightly higher. So it means that if possible, the trace must be pushed upward. Yeah, sometimes it's easier to delete the via and place it again, because as you could see, when I want to drag the via, sometimes it makes issues, it makes problems. So even this. I don't know if I gained some space. I don't think so. Maybe a millimeter or two. So now it seems that some of the tracks should be or must be moved to another layer. If the track is composed from multiple segments, it always causes issues. So as you can see, I sometimes have to drag each segment of the track before it starts behaving as I want. I don't understand why KiCad acts like this. If you want to move to drag a via, it's sometimes an impossible problem. But obviously we all need the cadence importers. For sure, we're only importing designs with KiCad users. Okay, it's subject to change, but not at the moment. Not now. If you asked me if I like this design, this PCB layout here, I would definitely say I wouldn't. But it's a process. It's a draft version. It's my first take, so it is what it is. It will be only better. So don't hesitate to make changes. PCB layout job is a constant change. Yeah. Maybe this way will help a little. Yeah, maybe yes. So we have only 2 more. I thought there is 10 of them. Okay, 2 more. I will start with these. With the short traces, because I want to avoid, again, I want to avoid crossings. So yeah. Okay, there is not enough space. You can see it. So we have to create this space by deleting the via and routing again, because it can't be dragged, as we all know. Impossible. As I said, impossible. You have to delete it and route it again. I don't know why. I don't know why, but you have to. Okay. Okay. Okay, so now I'm making space for the 1.8 volt via. Okay, whatever. No. Okay, so it will be here. Not a big deal. Okay, so I wanted to fan out all the signals for the test points, all the traces for test points. with some culture, of course. Okay, and these 4 routes will go almost okay. And we said we have 18, not 18, 16. It means 4, 4. So I will create groups of 4. That will be later improved. So I think I will do this. No, this. Yeah. So I'm checking the current time. Okay, so we can copy the layout now. A little. Yes. Yeah, these unconnected end traces will appear in the DRC, which is good. I will delete them later. So again, a group of 4. Just to copy the same pattern, just for the aesthetics. It's not very functional, but aesthetics. Okay. Okay, so what we have done, we have connected all the voltage translators with the RPI, with some struggles that are natural and innate to each PCB layout. Yeah, I'm finishing the physical connections with the bottom layer traces. Not a big deal. It's a funny job. Yeah. So what we have to do yet to connect these two channels, there will be changing of the reference plane and routing them in the bottom layer, connecting these components with the RJ45. There are 3 layers, 3 routes. This is, I think, the power related routes. Yes, battery, okay. We have 2 more. I forget, we have 2 more. Okay. Okay, I will improve this section. Definitely that's something I can improve, and it will look much better. But this time I think I'm done. I have to conclude the stream because I have another appointment. Yeah, I think, I don't know, maybe I will continue offline and present the result next time shortly, or maybe I will finish it next time. I'm not sure yet. So anyway, thank you for being here. Thank you for watching. I appreciate your presence. I appreciate your questions. And yeah. I think it looks good. Yeah, even the, yeah. I will make it better, but yeah, this way. Oh, this route is awful. Yeah, definitely there is a lot of work to be done, but it will be nice. Thank you, and see you next Thursday. Bye bye. Yeah, I almost forget. If you want to support me, there is a way. You can support me with enrolling with a course I made for 𝗶𝗶𝗀, KiCad for beginners, essentials of KiCad, symbols, footprints, library management, schematic routing, PCB layout, manufacturing data export, everything essential to start with KiCad if you are a beginner, complete beginner with ECADS, or if you are coming from other system. And here is, let's say, more advanced course for, I call it for makers, when you can design this RP2040 to dual core MCU to power supplies. Bunch of digital inputs, analog inputs, digital outputs, to USB-Cs, SD card, M2 connector, LEDs, buttons, everything is there. So again, library management, component management, but more advanced board. Differential pairs, impedance matching, this type of things is supported here or included here. So if you want to support me, 𝗏𝗏𝗀, KiCad for beginners, KiCad for makers. Thank you and see you next week. Bye.